Today we're going to learn how to graph rational functions. This is the second part of a three-part series. So the rational function that we'll be graphing will be a little bit more difficult today. In this case, it's f of x is equal to x squared minus x minus 2 over x minus 2. As you may remember from part 1, our first step is to fully factor the numerator and the denominator of the function. So let's try to factor the numerator. So we have f of x equals, and you might notice that to factor the numerator, we get x minus 2 times x plus 1 in the numerator. We leave the denominator alone. We factor it that way because if you remember, we're looking for two numbers whose product is negative 2, but whose sum is negative 1. And these are the factors. Our step 2 is to cancel like factors from the numerator and denominator. So you might notice that we have x minus 2 in the numerator and x minus 2 in the denominator. So we can cancel those. X minus 2 divided by x minus 2 is 1. However, we must keep a list of these factors, of these cancel factors, as they will become holes in your function. So we will keep track that x minus 2 will be one of our holes. Or rather, I should say x minus 2 is equal to 0. And therefore, x is equal to 2, because what we're looking for is the value that will make the denominator a 0. And therefore, 2 will make our denominator 0. And 2 will be one of the holes in our function. So we might notice that after canceling those factors, we get f of x is equal to x plus 1. And our very next step is to find the vertical asymptotes, which is basically to find the value that will make our denominator equal to 0. But there is no denominator except for 1, and therefore there are no vertical asymptotes. Our next step is to find the horizontal asymptotes. And if you remember, when we have a function, we look at the degree of the numerator and denominator. And our function, our numerator has a degree of 1. Our denominator just has a 1 in the denominator, but you might remember that's the same as saying 1 times x to the 0. And so the degree of the denominator is 0. And we've learned that when the degree of the numerator is larger than the degree of the denominator, we have no horizontal asymptotes. So in this case, there are no horizontal asymptotes. And our next step is to find the x and y intercepts. So once again, our function is f of x equals x plus 1. To find an x-intercept, if you remember, that's when y is equal to 0. So we say 0 is equal to x plus 1, which makes x equal to negative 1, and that is our x-intercept. The y-intercept, you might remember, is when x is equal to 0. So we'll say y, or f of x, is equal to 0 plus 1, and therefore y is equal to 1, and that is our y-intercept. Our next step is to check to see if the graph will cross the horizontal asymptote by setting the reduced function equal to the horizontal asymptote in solving. But as you remember, we have no horizontal asymptote, so therefore we don't have to worry about it crossing it. So this does not apply in this case. Okay, so our next step is to put a bunch of values into a table and to try to graph the function. Before we can do that, we should look at some of the other things that we have discovered. First of all, we know there are no vertical asymptotes. We know that there is a hole at x equal to 2. And if we look at the table that we created above, all we did was take our original function, which, if you remember, after canceling, becomes y equals x plus 1, or f of x is equal to x plus 1. When x is equal to 2, we'll notice that the y value is 3. So there is a hole in the function at 2, 3, and there's our hole. The other thing we should look at is one of the things we discovered, which was there is an x-intercept at -1, 0, and a y-intercept at 0, 1. So we should plot those points. So the x-intercept at -1, 0 is right there. And the y-intercept at 0, 1 is right there. And we should plot the remainder of the points at this from our table. So you notice that we have when x is -4, y is -3. So we'll put that there. When x is -3, y is -2. -2, -1. -1, 0 we already put in there. 0, 1 we already put in there. 1, 2 is right there. Our hole is at 2, 3. We then have 3. So we have all these we've plotted. And now, of course, we'll plot 3, 4. And finally, 4 and 5. Don't forget that the hole, let's just circle that, was at 2, 3. So right there where our hole is in the function, which we discovered previously. And now all we have to do is draw a line through these points. And there is our line, almost through the points. I was a little bit off. And we can see this is a linear function. However, if you remember, originally, it certainly before we cancel out the factors, we had a rational function, and that's why we have the hole at 2, 3. So just by looking at this function, y equals x plus 1, we would say, why in the world would there be a hole there? And that's because our original function was quite different, and therefore, after we canceled out the factors from the numerator and the denominator, we created a hole in the function. So if you follow all these steps, that is what our original function, y equals x squared minus x minus 2 divided by x minus 2 looks like once we graph it. And I hope you enjoyed the show, and I hope you got something out of it. And now it's your turn. Here's a problem very similar to the one that I just demonstrated on the screencast. If you're having any trouble, you might want to rewind the screencast to see how you do each part of this. See how you do. Good luck, and see you again next time.